Go to TAPgiles.com to learn dreams, engage my services, and support the channel. In the last video, I taught how to store many values into one variable, and now I'll show how to use a special optimization just for storing ones and zeros. There's another shortcut you can use to reduce the number of gadgets per row. So like, think of this as a row of decoding that value. We can reduce that by 1 if we and it's reduced by 1 for every single row. So if you have like 20 rows, it'll be reduced by 20 gadgets, which is pretty sizable. But this trick only works if you are using binary numbers, which just means instead of this being a range from 0 to 1,000, it's a range from 0 to 1. So there's only 2 different numbers. So we need to reset that one first. Set this to 1. So from 0 to 1 is all we can set that to. So, and all these need to be binary as well. So I'll change all of these to binary. Alternatively, you can just use a switch, which also sends a 0 if it's off and a 1 if it's on. So you can use that instead if you want to. But the rest of it will work the same. So this has 2 different values. So this needs to be multiplying by 2. And so does that. And then over here, these need to have 2 at the bottom as well. And that one as well. Cool, so it's all still working. We have a 0 or 1 in each slot, and it's being reflected in the decoded thing over here, which is cool. But now we can optimize this by doing this in a different order. So here we worked our way up, and then when we decoded, we worked our way down. We're going to flip this on its head. So the part of this logic we are simplifying is this divide. So as we saw earlier, you can use the blend mode called modulate to multiply this value by something, but you can't use, there's no wire blend mode for divide. But this modulate means you don't need a gadget to multiply that value. You just do it straight in the same gadget as the calculator. So we'll be doing that. So if we copy, but we'll do it in the same kind of order. So get that. Right, so we've got, at the moment we're storing those switches up here. And so let's say the top one is on. That one's in the middle. That one's, no, it's the other way around. So this is how these are being stored, and this is a separate case. So that's being stored and then bumped up, that's being stored and bumped up, that's being stored. And then we want to get it out in the kind of reverse order, and we're going to do that by multiplying. So dividing was used because we need to move stuff down slots. So if we want to use multiplying, we need to only move them up slots. So for that, we want to move all of these down, all the way down here. So they're beyond the slots entirely, and then we'll kind of move them up one by one. So we need to divide by the sort of maximum value that this can go to. So if we go, if we just do that and turn that on, so we're getting up to 7. So this is the part ignoring the negative. So we divide by 1 above that number. So we divide by 8, like that. And now we can, that's moved all these down here. Now we want to move them up again by going like that. And that means multiplying by 2 to move them up one slot, because each one slot is multiplying by 2. So wire that in there. Use the modulate mode with L1 and X. Change the setting to 2, so now it multiplies it by 2. And then the remainder after division of 2 as normal. And it's getting 1.7 because it's got these other things that we're dividing. We've already divided by 8 and stuff. So we need to round that down with the calculator. So we've got the remainder after division, and we've got a rounding down thing, but we're kind of doing it in the other order because we're going bottom up. If we get a switch now for that, it's a more visual way of understanding it. So now that's being properly represented there, and then we just pass it on up. So we move that up like that, wire that in, make sure that's on modulate, so it does the same thing again, and now that is tied to the next one up. And then we do it again. Let's get the top one. Oh, make sure it's modulating. And there we go. So now we've got encoding and decoding, and the encoding only uses one per row. If we just ignore these, when you've got actual switches, it's only 1 or 0 anyway. So we can just delete those and wire them in anyway. So 1 gadget per row to encode, and 2 gadgets per row to decode. And it's getting that all properly like that. And this can go up to 25 bits. So now let's expand this out to actually have 25 of these, so we can prove it works. So we've got 1, 2, 3, and then we'll copy a load more. 4, 5, 6, 7, 8, 9, 10. Okay, so we've got a ton of them. And then this is the 25th one, right at the top. And then you just wire them all into each other. And I think for this one, yeah, the modulation is working as we go. So now, because we're multiplying by 2 lots and lots of times, this one will move up and up and up these slots. So it'll get to a much higher number. And the last one we add will be the lowest number in the slots. And then that one into there, and then that saves it. Cool, and then we decode it all over here. That one goes at the top still. And then we want a load more of these, so this would be 4, 5, 6, 7, 8, 9, 10. And then we start wiring them in. The annoying thing is, for some reason, it doesn't keep the modulate for these ones, for the A, only for the B. So we have to go into each of them and do the multiply. Right. Oh, we need to divide by the max number again. So you can actually do a useful thing where you select all the calculators and then turn one of them on, and it turns all the other selected ones on. And this will tell us our number. So we want a full number here, so it's that 16 million number. So we need to divide by that plus 1. So 16,777. And then 215, so we'll put 216. There we go. So it's doing something, and now when we turn them off, it turns off in the same row. So the bottom one, and the negative still works. Cool. So now we have 25 ones or zeros being encoded into a variable, and then that variable is being decoded into 25 ones or zeros coming out the other side. So we can turn on persistence, for example, persist in dream, and now we can save I've picked up that gem and that gem, but I haven't picked up that gem. And then when it reloads the scene, it says, oh, you've picked up that gem, so I'll destroy it. And you haven't picked up that gem, so I won't destroy it. So you can remember a whole load of stuff just in one variable, and kind of restore the player's progress just automatically. And that's what's going on in here. You've got the decode stuff going up. You've got the encode stuff going up as well. And it all just costs less than 1% to do all that. So that's pretty cool if you want to make like a pixel drawing app like I did earlier. Thanks for watching. I hope you learned something interesting. Go to patreon.com/TAPgiles to learn something new every day.